Hi everyone, welcome back to Dave's Math channel. I'm your host David Tare, and this is my continuing feature on the Math Lovers book. And every Saturday I feature a new biography because I have a section in Volume 2 on biographies of mathematicians. I have biographies of 80 famous mathematicians throughout history, listed chronologically, and I'm reviewing them all one a week. And today I'm up to the eighth one on my list, and that's Hero of Alexandria. And he lived from around 1080 to around 780. I don't think we know the exact years. But here's a picture of him, kind of a big guy with a big beard. I don't know how accurate a depiction this is. But he was pretty famous. I mean, he did a lot of amazing stuff. He was, I guess, another polymath, you could call him, kind of like Archimedes. Not only was he a great mathematician, but he also was a pretty great inventor. He came up with several really amazing gadgets, I think, for his day. I mean, we're talking about, ancient times, shortly after the birth of Christ. And he invented a wind engine called a heliopile. And he also invented well, I can't even read this here. A force pump and a wind powered organ. Yeah, if I'm not mistaken, the heliopile was a steam turbine, actually. It wasn't a steam engine, but it was run by steam. It was a little rotating device that was heated by steam, and it would rotate due to the evaporation of the steam. So it could have been a steam engine if he scaled it up, or if the ancient Greeks had thought of scaling it up, but I guess they didn't. And I heard he even used it to open doors, and it made it look like the doors were opening by themselves. I think he scared a lot of people with that invention. I remember learning. But he did some pretty amazing things for his day, and not only that, but he was also a mathematician. And I think the most amazing formula he came up with was he came up with a pretty amazing formula for the area of an arbitrary triangle in terms of the lengths of its sides. The formula is square root of s times s minus a times s minus b times s minus c, where a, b, and c are the lengths of the side, and s is half of the perimeter. And I don't know how he came up with this formula. It's pretty difficult to derive. I've derived it. I've derived it using vector algebra. And they didn't have vectors. He didn't have vectors, so I'm not even sure how he derived this formula. But he did, and pretty amazing formula, pretty amazing guy. Oh, the other thing I think I should mention about him, I don't know if I mentioned it here, but he classified these six types of machines he called simple machines. They were the lever, the pulley, the wheel and axle, the inclined plane, the screw, and the wedge. And I think every machine, at least every machine that was known in ancient times, was made up of these six, different types of simple machines. And I think it's kind of true today, even. And, you can apply math to kind of explain how these machines work. I did this when I was in elementary school. I remember learning about the principle of a lever, which, Archimedes discovered F1, X1 equals F2, X2. And, the pulley, you can multiply them so that you get what's called a mechanical advantage, like you do with a lever. And similarly, with an inclined plane, you get a mechanical advantage by dragging a heavy object up an inclined plane. And you know, wheels. I mean, just about every vehicle in the world has wheels, and so. But I don't want to go into that in more detail. But pretty amazing polymath, I'd say, which is why I put him on my list. So that completes my profile of Hero of Alexandria. And thank you for watching. Long live math, and I'll see you guys next time. Bye.